Section 6.5 of your textbook covers the topic of complex rational expressions. A complex rational expression is a rational expression that has one or more rational expressions within its numerator or its denominator. There are three examples shown. In the first complex rational expression, we can see that the denominator contains the rational expression 1 over x squared. Our second complex rational expression actually has one rational expression in the numerator and another rational expression in the denominator. And our third example contains two rational expressions within its numerator and also two rational expressions within its denominator. In the slides that follow, we will discuss two methods of simplifying complex rational expressions. Each method has some advantages and some disadvantages. So it's important to understand both methods so that you can select and use the most efficient method for each problem. Our first method is the division method. To simplify a complex rational expression in this way, we add or subtract to obtain a single rational expression in the numerator and in the denominator, and then we divide. Let's do two examples. In example number 1, we see that our numerator is 120. That's already simplified, so let's work on the denominator. We have 1 plus 1 over x squared. Well, in order to do that addition, we need to rewrite 1 as x squared over x squared so that we have a common denominator. Now we can add those two rational expressions within the denominator of our complex rational expression. So we have 120 in the numerator, and in the denominator we now have x squared plus 1 over x squared. Now to continue our simplifying, we simply need to realize that division by a rational expression is equivalent to multiplying by the reciprocal. So we can write 120 times the reciprocal of that rational expression that's in the denominator. And its reciprocal is x squared over the quantity x squared plus 1. Now we finish the multiplication, and we see that our rational expression cannot be simplified any further, so we've arrived at our answer. What about example number 2? Slightly more complicated because there are more rational expressions within the complex rational expression. But we can work on the numerator and denominator separately. So in the first case, the numerator, we are adding two rational expressions. The LCD would be x times the quantity, x minus 3. So our first rational expression must be multiplied by that quantity x minus 3 over x minus 3. And our second rational expression must be multiplied by x over x. Now our two expressions have the same denominator, so we can add them up. Notice that when adding the expressions in the numerator, we first have to distribute. So we have 2x minus 6, and then plus 1x. That's a total of 3x minus 6 for the numerator. In the denominator, we still have that LCD, x times the quantity, x minus 3. All that work was simplifying the numerator of our original complex rational expression. Now let's turn to the denominator. We need to do some subtraction, which means we need to write both expressions with a common denominator. In this case, the LCD of 3x and x would be 3x. So our first rational expression stays the same. Our second rational expression has to get multiplied by 3 over 3. Now we can combine those numerators. It's simply 4 minus 3. So our numerator is 1. And then our denominator is that LCD, which was 3x. Now at this point, we see that we have a single rational expression in the numerator divided by a single rational expression in the denominator. So we can use the reciprocal to multiply. So we have 3x minus 6 over x times the quantity x minus 3 times 3x over 1. Note that since we're multiplying these expressions, we can simplify by removing any common factors we see. So we can remove an x from the numerator and the denominator. We also might want to look at that 3x minus 6 and factor it as 3 times the quantity x minus 2. In this case, doing the factoring doesn't result in any common factors with the denominator, so we can simply write our answer then. We have 9 times the quantity x minus 2 all over the quantity x minus 3. Let's use the same two examples to discuss method number 2. The second method involves multiplying by the LCD. To simplify a complex rational expression by this method, we're going to multiply both the numerator and the denominator by the LCD of all rational expressions within the complex rational expression. Let's look at example number 1. In this case, there is only one rational expression within our complex rational expression, and it has a denominator of x squared. So the LCD to use for this problem is x squared. What we're going to do is multiply both the numerator and denominator of our complex rational expression by x squared. In the numerator, we simply have 120 times x squared. In the denominator, we need to distribute that x squared to both terms. So first we have x squared times 1, that's x squared. And then we have x squared times 1 over x squared. Well, that would be x squared over x squared. We can simplify that. That's just 1. So our answer, once again, is 120 x squared over the quantity x squared plus 1. What about problem 2? Slightly more complicated because we have more rational expressions, but again, we'll look for the LCD of all those rational expressions within the complex rational expression. So our denominators are x, x minus 3, 3x, and x. The LCD of those expressions is 3x times the quantity x minus 3. So we need to multiply both the numerator and denominator of our complex rational expression by 3x times the quantity x minus 3. Once again, we'll be careful to use the distributive property as we do this multiplication. So we multiply our first term, 2 over x, by that LCD. In this case, we get 6x times the quantity x minus 3 all over x. Multiply our second term by that same LCD. In this case, we have 3x times the quantity x minus 3 all over the quantity x minus 3. Let's go to the denominator and again distribute. Multiplying by the first term, we have 12x times the quantity x minus 3 over 3x. Then multiplying by the second term, we have 3x times the quantity x minus 3 over x. Now the real advantage of this using the LCD is that the rational expressions within the numerator and denominator should be easily simplified by removing common factors. Our first term in the numerator, we have an x in both the numerator and denominator, so we can remove those. Our second term contains a factor of x minus 3 in both the numerator and denominator, so we can remove those. Within the denominator of our complex rational expression, we can simplify 12x and 3x, and that simply makes 4. And then we can simplify 3x and x down to just 3. This allows us to easily simplify the numerator and the denominator. In the numerator, we have 6 times x, or 6x, and then 6 times -3, or -18. Then we have to add 3x. So 6x and 3x leads to 9x in the numerator. And then we had that -18 as well. What about our denominator? Well, we have 4x and then -12, and then we have -3x and then +9. Because we're distributing -3 through that second binomial there. So that simplifies to x minus 3. And if we factor the numerator, we'll see that we have 9 times the quantity x minus 2 over the quantity x minus 3, which is the same answer we achieved with our first method of division.